Hello everyone. Today we are going to solve the GFD problem of the day. So let's quickly go and check what is the today's problem. Yeah. Okay. Skip. Okay. I have already solved this problem. I'll try to explain you guys how I solved this problem and how what is the approach you can follow to solve this problem. Let me just quickly go to the problem. The problem says buy maximum stocks if I stocks can be bought on the ith day. Okay. In a stock market there is a product with infinite stocks, so there is a product and with infinite number of stocks. The number of stocks are infinite. The stocks prices are given for n days, okay, where the price I denotes the price of the stocks of the ith day. Okay, so price I denotes the stocks price on that particular day. Okay, so there is a rule that a customer can buy at most I stock on the ith day. Okay, so let's say per person on the first day can buy only one stock, on the second day on two stocks, something like that, I think. So if the customer has an amount of k amount of money, okay, if he has k amount of money, then the task is to find out the maximum number of stocks a customer can buy. So here is the problem. We can see the problem. Task is to find the maximum number of stocks he can buy. Okay, so customer can buy within that period of time. Okay, so we have a price array 10, 7, 19, and k is the amount, I think, and output is 4. So he can buy 4. How can he can buy 4? Here is they have given some explanation. Customer can purchase one stock on day 1, two stocks on day 2, and one stock on day 3. So 10, 7 into 2, yes, correct, and this method. So 43, so total price will be 43. How they have done is, like, on the first day we can buy only one, because in the question they have mentioned on ad day we can buy only I stocks. So on the first day we can buy only one, so we can buy this stock with value 10 on the first day only one time. On the second day we can buy this stock with the value as 7 two times, and the same for the third day we can buy this three times. So how they have buy one on the first day and two on the second day, and one again on the third day, because the value is maybe less for purchasing more on the third day. So that's why they bought four stocks, and the total value went 43. And anyway we are remaining up with the two, but that is not going to be anywhere useful because the prices value are start from 7. So yeah, so total number of stocks is we can purchase is 4. Our task is to find the maximum number of stocks. Similarly, you can read this example as well. What we have to do, we have to find the maximum number of stocks. So let's see what is the expected time complexity is n log n, and expected auxiliary space is n. Okay, and yeah, so you can understand from this that expected time complexity n log n simply gives you some idea of sorting, because for sorting we need n log n time complexity, whichever sorting algorithm you use. So this gives some sorting hint. This gives some hint that we have to use sorting, or just a kind of a hint. You can not take it grantly, because we are not sure right now. But when we when we try to approach this problem, just try to think in a that what if we sort this and then we apply any kind of logic, so that may work here. So I'll explain this problem approach using pen and paper, then I'll jump to coding. Okay, so let's meet on pen and paper now.
Okay, so let's come to pen and paper now, and we'll try to solve this problem. What is the our basic intuition behind this problem is we'll try to spend the minimum amount of money on the particular stock, and want to get the maximum amount of stock from by spending over that money. So we will be spending the minimum amount and maximum number of stocks we want. So how we can achieve this? So basically in this example, we will first try to see the, let's say we begin with the day 1, and will be consuming one stock here, two stock here, and three stocks here, and whatever the number of stock we are end up with. So that will be the basic approach. And how we can go with this approach, that by spending minimum amount, how we can get the maximum number of stocks, because we want the maximum number of stocks in our problem. So let's say we have amount, let's say 18. On day 1, here you can see we can buy only one stock on of value 13. So let's buy one stock. How many amount we have remain with the 5. On day 2 we can buy two stocks of value 4, so we can't buy two because we have remaining with the value 4, so we can buy only one, so we have amount left as 1. So now you can see we have bought here one stock, here one stock, and now on the day 3 we can't buy anything, day 4 we can't buy anything, on day 5 we can buy one because we remained with one. So on day 4, sorry, day 5 we have buy one stock, so we have buy three stocks. Total number of stocks we have bought here is, sorry, bought here is 3. So now what will be our approach to get the maximum number of stocks? Here you can see when on day 5 our stock value got reduced to 1. So means if we think that on one, first, second, third, fourth day if we didn't buy anything, so we can buy the 18 stocks on day 5th with stock value as 1. So now what amount of stocks we are buying here is only 3, and if you wait till the day 5 and you can buy the maximum stocks with 18, means maximum number of stocks you can buy is 18. So how we can do that? So basically you just think, you just try to spend your money in efficient way. So just if you know all these stocks amount, in reality you'll not be knowing that whatever the amount, what is the amount that will be on a fifth day. So basically you know that on fifth day you have the amount that on the stock value decreases to 1. So why can't we sort this array and just try to uh, spend our amount as per the stock's price? So let's say on for one stock 5 you can purchase, and then for 2 3 you can purchase 4 for 2, and you can purchase 4 and 4 you can purchase 2. Oh sorry, for 2 it's 3 and then 1. Yeah, correct. Okay, 3 4, okay, now it's correct. Basically I was wrong because we can't buy 18 stocks because on day 5th we can buy only 5 stocks, so maximum stock we can buy here is 5. Okay, so let's try to go with this approach. So if we check, if we try to purchase the stocks on day 5, so how many stocks we can buy? 18 minus 1 into 5, and then we are remained with 18 minus 5, it's 13. Okay, so now we have remained with 13. So you can see then what is the next stock we can buy here. So I have sorted this wrong way, sorry guys. So this is the next stocks we can buy because the next value of 1 after 1 is 2. So how many stocks we can buy for buy with 2, like 3, 2 into 3, you can see we can buy 3 stocks of value 3. So 2 into 3 gives us the 6, 13 minus 6 gives us the 7. Okay, so now we can buy stocks with value 3 of quantity 1. So 3 into 1, okay, we can buy actually 2, and we have the limit as 4, but we'll be buying 2 because we don't have that much. So you can see 6 1. Okay, so how many stocks we have bought? So here 5, here 3, and here 2. So 5, total 10 stocks we have bought, total 10 stocks, but previously we have ending up with 3. So basically what you will be doing is you will be sorting this array, and you will be try to spend as much minimum amount you can and get the maximum number of stocks. Hope you understood. Let's just quickly jump to the code. I'll try to explain you the code. Okay.
Okay, so let's try to solve this problem. So what we'll be doing is we'll be first taking this price of array into a price one name vector which contains pairs like integer, and we will name it as pair one. Now what we will do is we will iterate through this price array, and we will insert all the elements of that price array into the price one vector which has the pair, and the second component of our favor pair indicate that this is the amount of stocks we can purchase. Sorry, this value of that stock on a particular day. I'll be storing it with I plus one because that will be more useful for us. So now we will sort this price one vector. Why we have to sort, I have explained you. You can just go back and watch. Now what we want is the number of stocks, maximum number of stocks we can buy. So we will make the variable as maximum number of stocks as equal to 0. This will be our answer. And yeah, so that is it, I think. So we have to run a loop that will end when k value is less than or equal to 0. So we'll run this loop until our value is greater than 0. Now we'll iterate through this our price vector, which first value of that price vector is the value of that stock, and the second value is the number of stocks we can buy on that day. So we'll make a variable that is the value of stocks. So that is stored in the first pair, first component of her, and number of stocks is stored in the second component of that pair. Right now, our task is to check whether we have the enough amount of money, how many amount, how whether we can satisfy the number of stocks on that particular day. So if that is number of stocks on particular day is lesser than whatever the amount we can purchase. How we can find out that well stocks is the value of that particular stock, and uh, whatever the amount we have, what amount we have amount k, and val stocks is the value of the stocks on the particular day. So what this gives is, this gives us the value of stocks that we can purchase right now, and whatever, and number of stocks gives us the value that uh, we can buy these stocks we can buy on that day. And right now we have remained with the k capacity, and we can buy those stocks on that day. So if the number of stocks are lesser than whatever the amount left divided by the values of stocks, means we can buy this much stocks. But for that day we can buy n underscore stocks. So if it's lesser, so we will just uh, reduce the number of stocks into our value of stocks. This will buy whole stocks that we can buy because the value is lesser, and we will increment our MN, means maximum number of stocks, equal to uh, number of stocks. So let's say if we can't buy, then we will go in else. We will go in else, and what we will do here, we will check. We will check. No, no. We will just simply buy those. Buy that number of stocks that we can actually buy. So how many? Let's say we store the number of stocks in NS, and so the K is the amount that we have currently in our hand, and what is the value of stocks? It's well underscore stocks. So this is the amount of stocks we can buy. We'll minus that number of stocks. We will minus that value. So NS is the number of stocks we can buy, and what is the value of stocks? And we will increase our maximum number of stocks as NS, right? So here, as you can see, when k is greater than 0, we will keep on buying. But when if let's say uh, if k divided by number of stocks is lesser, means is if it's equal to 0, then we will not be able to buy. So we'll put one condition here, Let's say our capacity is this, and what is the value of that stocks. If it's greater than zero, if it's greater than zero, then only we will enter into this if condition. Else we will be simply just take this loop, right? Because we have not that much amount of money in our hand, so we'll be just simply break, right? And we'll return answer as maximum number of stocks, right? Let me just quickly check and try and run this code. This compilation here, price one was not declared in the scope. So haven't we declared price one? Okay, we have not declared price one. Okay, right. What is the error now? Well, stocks equal to price of I was not declared in the scope. So we have to keep that when we iterate through this loop, iterate through the price vector. We should have a I that will be keep on incrementing after each iteration. What is the next error? Well, stocks was not defined in the scope. Well, stocks on line number 26. Well, stocks here is the spelling mistake. Mm, Calendar ready for evaluation. Think I have done it correct. What is the error? Val is not declared. No, okay, okay. Sorry, I have done a lot of mistakes in this code. So simple mistakes. 30 14 point expectation. What is sorry exception? I'm not sure what this error. Let's try to make it on floor. I try to make this as floor. I don't want any kind of floating error. Because this will work or not, I'm not sure. Okay, so let's say well stock 6 greater than 0 merely we will enter. Okay, let's submit. Okay, you can see it's success, problem solved successfully. Okay, now this is the solution. I'll provide the solution on GitHub. You can check in description. Thank you guys.